Evening, folks. Brian here, Geomagnetic Earth Watch on Friday, June 7, 2024. Hope you're all well. So, folks, we've already exceeded S2 moderate solar radiation storm or proton storm. This is obviously from the M9.75 flare from the departing region 3697. We are still climbing. Now, this was a very sudden rise. Let's take a look here. All right, so we're updated here. So these speckles, what looks like snowflakes, these are the actual protons impacting into the sensor array on the satellites. Let's give this a play. Okay, there you go, coming up. That is a substantial blast from the departing region. Okay, now for a little bit of education here. This is a diagram of Earth's magnetic cusps or funnels, which bring in the charged particles or funnel the charged particles back in through the magnetic poles to the Earth's core. Now, the energetic charged particles carried in the solar winds and during CME impacts and solar radiation storms, such as we're experiencing now, are going to funnel down to the magnetic cusps and into the outer core of our planet. And when interfering with the, or coming in contact with the atmosphere, creates what we commonly call the auroras. However, folks, when our protective shield is at 100% full strength, meaning the magnetic poles, geomagnetic poles, are more or less antipodal, opposite to each other, we have a organized, well-defined magnetic field lines which leave the south magnetic field, or pardon me, south magnetic pole, and circuit the planet and re-emerge back into the north polar cusp. However, during reversal, such as we are in right now, we no longer have any organized, stable magnetic field, such as described here. In fact, we end up developing multiple magnetic poles. So here's the situation, people. As I stated, in order to have a 100% full field strength, our geomagnetic poles have to be antipodal, more or less at opposite ends, approximately. But because we're on a geomagnetic excursion, it has destabilized and weakened our protective magnetosphere. One clue is, of course, the auroras that have been extending much farther south. I'll show you another indication. Before I do, so normally during proton events, solar radiation storms, they are confined normally to the polar regions because of those charged particles funneling down the magnetic cusp. This is why they restrict air travel around the polar regions once it passes a certain threshold. Problem is, we have weak points around our planet. I'll show you one example outside my home. So this is last January 28th when we were having some solar radiation storms. This is the main hydro line in front of my house. These are horizontal cross members. During the proton event, there was an induced current traveling across the horizontal bars. I'll play it now. Plasma. So normally solar radiation storms would not be of concern unless you're in the polar regions. But because our magnetic field is in a state of flux, it's changing, it's weakening, developing holes. We don't know where we're going to have be affected by these radiation storms. I just went outside and checked right now, and it's not doing anything, but numerous times at the end of last year when we had a series of solar radiation storms, we had quite the light show. So fires actually can be started from these induced currents. Something to take into consideration, because these lines are all throughout northern Canada. Fire starters. It's not just a case of hydro lines falling off during windstorms. So when you hear of other people saying, oh, it's okay, that's just confined to the polar regions, they fail to mention that our protective magnetic field is destabilizing and weakening and allowing more charged particles in. The obvious visualization is the auroras reaching almost down to the equator region. A little bit of education for you.